Okay, so in this lesson, we're going to talk about what makes triangles congruent. And, oh, I forgot to mention, in our Bell work, when we had two congruent figures, what was the postulate or rule that we could use that allowed us to say that angle C was congruent to angle V? Remember what that was? What that is? Something CP, C, congruent parts, corresponding parts of congruent figures are congruent, okay? So that's what allowed us to say that those parts were congruent. Those angles, pairs, and the side pairs were congruent because of the postulate congruent, or corresponding parts of congruent figures are congruent. Now we're just going to be working with triangles. So in order for two triangles to be congruent, we are going to have three pairs of congruent angles and three pairs of congruent sides. And if this isn't the case, if we don't have three pairs of congruent angles and we don't have three pairs of congruent sides, then the two triangles are not congruent. And you can usually identify that fairly easily when you're looking at a diagram of two or a picture of two triangles. So let's talk about how that might appear in two figures. So let's draw two triangles. We're going to have triangle. Now, these aren't going to be to scale, and they're not going to be perfect. And I'm only going to write them as right triangles because that will hopefully help me make them a little bit better in terms of congruent. So we're going to call this triangle SEA, triangle C. And then we're going to call this triangle, what are we going to name it? Three letters. MTV. Does that still exist, MTV? Kind of, sort of. So what we know is that we are given there's the two nicely drawn triangles, and then we're going to give this information. Triangle SEA is congruent to triangle MTV. Okay, so we said if we have congruent triangles, what has to be true is we're going to have three pairs of congruent angles, three pairs of congruent sides. So I started out with angle S. So angle S is going to be congruent to what angle on the second triangle? M, because S is in the first spot, M is in the first spot, so angle M. So I'm just going to go in order. Angle E is going to be congruent to what angle in the second triangle? T. And then angle A will be congruent to the only remaining angle, which is angle V. All right, sides. Side SE. That's going to be congruent to what side on the other triangle? MT. Then I'm going to go side EA is congruent to TV. And then what's my third side? SA. That is congruent to MV. Okay, so all of those things are true because these triangles are congruent. So what I think we've talked about how to label sides that are equal and angles that are equal. We're going to go ahead and do that again now, just to refresh your memory. So when we have angles that are congruent, we can show that by putting little arcs in those angles. So we know angle S is congruent to angle M. So I'm just going to put one arc in S and one arc in M. And because those both just have one arc, that means they are equal in measure. Triangle or angles E and T, they both have a specific mark. This says that that's 90 degrees. This says that that's 90 degrees. We don't have to put another mark in those places because 90 equals 90, right? But for A equaling V, because we want to make sure we're not confusing it with angle S or angle M, we want to show that A is congruent to V. So we're going to do 2 arcs for A and then 2 arcs for V. So if it's a 1 arc on one triangle, it matches up with the 1 arc on the other triangle. So this, even without knowing all this right here, we would say that we know S equals M and A equals V, or that they're congruent. And if obviously E is equal or congruent to T because they're both 90-degree angles. Now, with sides, I can't remember if we've done this either, but we aren't going to use arcs. We're going to just use like a little dash or slash. So SE, side SE, what color do we want to go there? Let's go black. Okay, so side SE is right here. I'm going to put 1 dash through that. And then the corresponding part on the other triangle, I would put 1 dash. So MT, I would put 1 dash. So that means those 2 sides are equal. So side EA, it's a different side than SE, so I don't want to just put 1 dash, so I'm going to put 2 dashes. And so its corresponding side on the other triangle, I need to make sure I use 2 dashes for it. And that is side TV, right? And then side SA, I want to make sure I can tell the difference between the other 2 sides. So I'm going to put 3 dashes there, and then that would be match up with side MV, so that should show 3 dashes. So these marks tell us what things are equal to each other. Dashes will tell us that sides are equal. Arcs will tell us what angles are equal to each other. Okay, and it's very easy. If we would have, if we don't have all 3 pairs of angles congruent, or all 3 pairs of sides congruent, then the 2 triangles are not going to be congruent. I'm not going to go over a problem where you look at that and you see that this is 40 and this is 41. They can't be congruent. Okay, we're going to talk about when they're congruent, what values have to be true. So let's do that. Okay, so we want to find the value of x that results in these triangles being congruent. So we have triangle, we could call this JKL, and we have triangle MNP. So let's first identify what, because the x represents an angle, right? So let's match up our angles. So angle J should match up with what angle on the second triangle? M, because they're equal, right? So I'm going to say J and M are together. And then angle K on the first triangle, it matches up with what angle? On the second? N. So then angle L, it matches up with angle P. So, anyway, so we know that J and M are both 55 degrees, right? K and N are both 45 degrees. L and P, we need to figure out what their measures are. They're going to be equal to each other. So how do we know what this angle measure is right there, angle L? How do we know what that third angle is in a triangle? Right. Remember, 3 angles in a triangle add up to 180 degrees. So what we're going to do is to figure angle L, the measure of angle L equals 180 minus 45 plus 55. What's 45 plus 55? 100, maybe? Yeah, it's 100. So 180 minus 100 would be 80. So angle L is 80 degrees. So what does angle P have to equal? Remember, they're equal to each other, so they're going to equal 80. They're both going to equal 80 degrees. So we can put in here This is 80 degrees. We have something for this angle already. What do we have for that angle? 5x plus 30, right? So we're going to say that 5x plus 30, that has to equal 80 degrees in order for the two triangles to be congruent. So what is x going to be so that when we plug it in there, we get 80 degrees? So it's a simple two-step equation. How do we solve for x in this case? We want to isolate x. What's the first thing we're going to do? How do we solve for x? Subtract 30. This is algebra now. So we have 5x equals 20? 50? 50. And then we're going to divide by 5, right? So x equals 10. Does that work if we let x equal 10 right here? 5 times 10 is 50 plus 30 is at 80. It is. That's what we want it to be because we want these two angles to be equal. So the value of x is 10. That makes these two triangles congruent. There's our answer. X needs to equal. Okay, so the information we have now is in terms of sides, right? And in order for two triangles to be congruent, all three sides have to equal, all three angles have to equal. So we're going to assume that the angles are equal. Well, yeah. And now we need to make sure that all the sides are equal. So let's match up what sides belong to match up from one triangle to the other. So let's start with side AC. So side AC on the first triangle is going to match up with what side on the second triangle? AC is 50, so I'm going to find the 50 on the second triangle, so that's DF. And then I have side AB on the first triangle. That matches up with what side? I don't have a 36 on the other one, do I? So that must be this DE, right? And then side BC matches up with the other side that's 30, so that's EF or FE. Okay, so we know AC and DF, they're 50. We know these are 30. These two need to equal what? They both need to equal 36, right? Because that side matches up with that side. So that's where our equation comes in. We're going to say that 2x plus 20 needs to equal 36, and we're going to find the x value that makes that happen. So again, two-step operation, subtract and then divide to find x, and then we'll check to make sure it's correct. So 180 minus 112 plus 25. What's 112 plus 25? 7, 137, and that would be 43. So both of those angles should equal 43. So we can put 43 here. But we need to figure out what x is so that when we add 17 to it, we get 43. So our equation x plus 17 equals 43. Subtract 17. So x needs to be 26. Okay, before I box that in, when I take 26 plus 17, do I get 43? I do, so there's my value for x that makes those triangles congruent. So two-step operation this time. We're going to have to subtract 12 to figure out what x is and then divide. So that gives me 20 equals 4x, divide by 4, and x equals 5. So I want this side, 4x plus 12, to equal 32. So if x equals 5, does that do that? 4 times 5 is 20. 20 plus 12 is 32. That does it. So there's my solution for x. All right.